Greetings to you, specially, and welcome to the Engineer Construction Lecture Hub. Still on the moment coefficient table, I just want to show us how we can commence our design navigating through the moment coefficient table, which is stated here, okay, which is stated here. So let's take, for example, we have this. Okay, we have this as an example. Okay, given concrete cover as 20 mm. Okay, we have it as 20 mm. We have CU, that is strength of concrete, as 25 Newton per meter square. We have that of steel as 410 Newton per millimeter square. Okay, so we did our loading, okay, of the slab. We have self-weight of the slab, which is 0.15 times 25. This is the density of concrete, reinforced concrete. This is the depth of concrete, which is 150 mm, but it's converted to meters, so it becomes 0.15 meters. So when you multiply this, you have 3.75 kilonewton per meter square. Okay, we have the finishings. We assume finishings as 1.2 kilonewton per meter square. We have unknown partition allowances. Okay, allowance. We adopted 1 kilonewton per meter square. So the total dead load GK becomes 5.95 kilonewton per meter square. Then the life load QK residential, that is the class of building, is 1.5 kilonewton per meter square. Okay, now the total ultimate design load W is the factored load. This is the factored load. So 1.4 GK plus 1.6 QK. When you substitute, you have 10.73 kilonewton per meter run, because in slab we consider per meter run. Then you calculate the effective depth. Okay, the effective depth is the overall depth of the slab, concrete cover, and half of the diameter of bar. All right, so when you substitute, you have 124 millimeter as effective depth. Now we are considering, now remember, this is the effective depth for the panels. Okay, this is the effective depth for the panels. This is the design load for the panels, except in some cases where we have point load. That means we have to incorporate it here, okay, because it will be those two that is acting on that slab. But if there is none, that means this design load becomes spreads all through that slab. So when you're considering the panels, this becomes your ultimate design load. Now when you look at, we say panel E. Okay, panel E is what we are considering in that slab, in a certain slab. Now in that panel E, it has a 4 meter by 3 meter area. Okay, so we have 4 meter as your LY, we have 3 meter as your L, 4,000 divided by 3,000. That will give us 1.3. Okay, 1.3. Now when you come to the table, this is 1.3. We have already established this already. Okay, we have established this already by the LY-LX ratio. Then you go back to that panel. That panel now is having two sides continuous and two sides discontinuous based on its position. Okay, so that is why we said the panel is considered as case 4. So if you look at case 4 now, this is case 1, case 2, case 3, case 4. So this case 4 has two sides continuous and two sides discontinuous. So this is the boundary condition that satisfy panel E. Okay, that satisfy panel E. So the panel is considered as case 4. Now we have 1.3 as our LY-LX ratio. Then we have case 4. So we go back, okay? This is case 4. Then we trace to 1.3. Okay, this is 1.3. So we have, this is our negative edge moment. This is our positive span moment. Okay, so you have to write out this and this. Okay, you write it out, you can see it here. You can see it here. We have edge negative 0.69, positive, that is the span, 0.051. You can confirm it again. You can confirm it. You can see it. This is case 3 we are looking at. All right, 0.069 as negative edge moment. We have 0.051 as positive span moment. All right, so once you have done that, the next thing you're going to do is to trace this. Okay, you have to trace this to the long for the long coefficient. All right, so let's trace it. You trace it down to this point, so you can see long span coefficient. So this becomes 0.045 for the edge negative moment. This is 0.034 for the positive span moment. So you can also confirm it here. We have long span edge negative 0.045, which is what we have here, 0.045. Then you come back, you have the positive 0.034. You come back here, you confirm it, 0.034. All right, so once you have highlighted this is what you need to design this panel E. All right, so you proceed with the design. All right, so this is how you're expected to navigate through the moment coefficient table. Okay, this is how you're expected to navigate through your moment coefficient table. If this is the first time you're coming across this video, do well to follow this page for more updates as regards to construction. Thank you very much for your time, and do have a wonderful day. See you in the next episode. Thank you. Bye.